Quadratic equations, from curves to solutions. In today's lesson, we'll explore one of the most beautiful and practical topics in algebra, quadratic equations. Quadratic equations appear everywhere around us, from the path of a football in the air to the design of bridges, satellite dishes, and roller coasters. Today, we'll understand what quadratic equations are, learn different methods of solving them, and discover how they help explain the real world. Let's begin. The shape of change. Every quadratic equation creates a unique curve called a parabola. The standard form of a quadratic equation is ax squared plus bx plus c equals 0, where a is not equal to 0. If the value of a is positive, the parabola opens upward like a smiling bowl. If a is negative, it opens downward like an upside-down bowl. This simple equation produces one of the most important curves in mathematics. Anatomy of a parabola. Let's understand the important parts of a parabola. The vertex is the turning point of the curve. It represents either the maximum or minimum value. The axis of symmetry is a vertical line passing through the vertex, dividing the parabola into two equal halves. The y-intercept is found by substituting x equals 0, and it always equals the constant term c. These features help us draw and understand the graph of any quadratic equation. Method 1. Solving by factoring. The first method is factorization. This is the quickest method whenever the equation can be factored easily. We rewrite the quadratic expression as the product of two factors. Then we apply the zero product property. If one factor multiplied by another equals 0, then at least one of the factors must be 0. This method works best when the coefficients are small integers. Method 2. Completing the square. When factorization is difficult, we can use completing the square. In this method, we transform the equation into a perfect square trinomial. We begin with the standard form. Move the constant term to the other side. Add the square of half the coefficient of x to both sides. Now the left side becomes a perfect square. Finally, take the square root of both sides to find the solution. This method is also useful for identifying the vertex of the parabola. The quadratic formula. The most powerful method is the quadratic formula. The formula is x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. This formula works for every quadratic equation, whether or not it can be factored. It always provides the correct roots. One important part of the formula is called the discriminant, which is b squared minus 4ac. The discriminant tells us the nature of the roots even before solving the equation. The power of the discriminant. The discriminant helps us predict the number and type of solutions. If b squared minus 4ac is greater than 0, the equation has two distinct real roots. If it equals 0, there is one repeated real root. If it is less than 0, there are no real roots because the parabola never touches the x-axis. This simple calculation provides valuable information before solving the equation. Real-world applications. Quadratic equations are much more than classroom mathematics. They help calculate the path of a thrown ball. Engineers use them while designing bridges and arches. Scientists apply them to study projectile motion. They are used in aerospace engineering, sports science, physics, and computer graphics. Whenever an object follows a curved path, quadratic equations are usually involved. Choosing the right method. When solving quadratic equations, always choose the simplest method. First, check whether the equation can be factored. If there is no middle term, use the square root method. If neither method works, use the quadratic formula. Remember, the quadratic formula always works. But learning all methods helps you solve problems faster and improves your mathematical thinking. Key takeaways. Let's summarize the main ideas. Identify the values of a, b, and c. Choose the most suitable solving method. Practice regularly to improve speed and accuracy. Quadratic equations are not just mathematical expressions. They are powerful tools for solving real-life problems involving motion, design, engineering, and science. Example using factorization. Let's solve an example. Find the roots of the equation. 2x squared minus 5x plus 3 equals 0. First, split the middle term. Rewrite the equation as 2x squared minus 2x minus 3x plus 3. Now factor by grouping. We obtain x minus 1 multiplied by 2x minus 3 equals 0. Therefore, either x equals 1, or x equals 3 by 2. Hence, the roots of the equation are 1 and 3 by 2. Example for finding roots, using the discriminant. Now let's solve the same equation using the quadratic formula. Here, a equals 2, b equals -5, and c equals 3. Substituting these values into the formula gives x equals 5 plus or minus square root of 25 minus 24 divided by 4. This simplifies to 5 plus or minus 1 divided by 4. Therefore, the roots are 1 and 3 by 2. Notice that both methods give exactly the same answer. The discriminant here is positive, which confirms that the equation has two distinct real roots. Let's recap today's lesson. We learned the standard form of a quadratic equation. We explored the parabola and its important features. We studied three methods of solving quadratic equations: factorization, completing the square, and the quadratic formula. We also discovered how the discriminant predicts the nature of the roots before solving the equation. Finally, we solved practical examples using both factorization and the quadratic formula. Quadratic equations are among the most useful mathematical tools in science, engineering, architecture, sports, and technology. Thank you for learning.